Hello. In today's lesson, we will discuss water and water solutions. To begin with, let's start with a brief discussion on household water. Water, like energy, is a valuable resource that is too frequently squandered. Very often we don't understand the value of water. Now, how many of us, while brushing the teeth, turn the water and leave it on? Now, do we understand that in this country we have enormous supply of water? But does not mean that we really have any amount of water that we can actually spend? Well, in Florida, we have an acute shortage of water. This year especially, the rains have been very scanty. Now, the groundwater supply is not being replenished. If you keep using our groundwater supplies, the level of groundwater is going to decrease and the seawater is going to encroach, and life in Florida will be difficult. Now, how many of you have been following the story of the controversy, the water controversy among Georgia, Florida and Alabama? Now, Georgia is at the moment experiencing one of the severe droughts in its history. The lakes are drying out, and water from lakes in Georgia are being pumped into Florida and Alabama to take care of endangered animals. Now the question is, who has the right for this water? Now, if I go on, I can keep talking for the whole day about the value of water and how important it is to have a policy of conservation. Now, all of us need to understand that. Now, residential water use only accounts for 47% of all water supplied to US communities by public and private utilities. Fresh, clean water is scarce and getting more so. Of all the water on the earth, less than 3% is fresh water. And most of that fresh water is locked up in glaciers and ice caps, or it is too deep underneath. Most of fresh water is actually locked up in ice caps or underground aquifers or groundwater. Now, of the fresh water available in rivers, lakes and the ground, an increasingly large fraction is polluted by biological, chemical and radioactive contaminants. You see, our present civilization has not shown any regard towards clean water and conservation and making sure that our waterways and our water reservoirs are kept clean. Now, how many of you think about this? Well, I don't want to say how many of you, how many of we. I am equally guilty. How many of us think about the contamination we cause to our water supply when we throw fertilizer on our lawns and use sprinkler systems to water it? Those fertilizers are systematically being washed into our groundwater systems, into our reservoirs, into our lakes, into our rivers, and we are continuously polluting our water resources. There is need to create awareness in the people to use household water more efficiently without reducing services. Now, if you are serious about conservation, you can easily reduce water consumption by 1/3, which will bring a substantial savings on your monthly bills, as well as benefiting the environment and community at large. I know it because when my younger daughter is not home, our water bill is almost a half of what we normally pay. Well, my little daughter tends to take long showers. You see, you can cut down on all your water use. When you wash plates, your dishes, how many times you let the water run when you are putting soap? Well, there are many ways you can save and conserve water. At the same time, there are many ways we can keep our water supplies clean by taking an oath maybe. Well, I will not throw contaminant materials outside into the lawn or into the lake or into the rivers to contaminate. Well, all these things are part of water education. Now think of several ways you can conserve water. Now look at some of the simple ways you can conserve water. Fixing leaks and replacing shower heads and faucet aerators with water efficient models will typically pay itself within a year. Still, more water can be saved by recycling grey water. Well, we do that a lot in Florida. Well, grey water is actually used water we throw out into the sewers. That water can be treated and can be used for watering lawns and plants. In order to understand the issues involved in safe water supply, we need to understand the basic properties of water. So in this lesson, we are going to concentrate more on the basic properties of water. Now, what are some of the basic properties of water? Water is a unique substance in the sense that it is the only natural substance that is found on earth in all three states. You see, water is the only substance that can exist as solid, liquid and gas, all at, well, not at the same temperature, but we use solid water, ice, liquid water, that is normal water, and of course there is a lot of water vapor in the atmosphere. Now, when water vapor condenses to gas, well, water vapor condenses, it becomes liquid water. And liquid water evaporates to become vapor. These changes we have actually talked about in one of our earlier lessons. In the same way, water freezing turns it into a solid, and the solid water melts to become liquid water. Solid water can change into gas. You remember we talked about it? The process is called sublimation. In your freezer, if you open your freezer, you can actually see solid ice directly becoming vapor. And vapor directly becoming solid. Have you seen that happen? What is frost? On a cold day when you have frost, if your car is parked outside, you see your windshield will be covered with ice. The water vapor in the atmosphere has directly become solid. So you can see water can change into all these different forms. One important property of water is that it is a good solvent. What is a good solvent? Water is called a universal solvent because of its ability to dissolve many substances. You see, we very often go and wash our hands using water. We take bath in water. Why? Water will dissolve a lot of materials. We take bath in water hoping that the dirt that has been accumulating on our body will get dissolved and gets washed away when we take bath in water. You see, water is a universal solvent. In living things, these dissolved molecules of nutrients are carried from one part to another using the circulatory system. In fact, all this is made possible by this important property of water. Another or other important properties of water that makes it very useful to us is the very high specific heat. Do you remember what specific heat is? We discussed that in lesson 2. And also its very high latent heat. In order that water may be heated to a higher temperature, you need to supply a very large quantity of heat. Now, do you remember the value of specific heat of water? 1 kilogram of water requires 4,200 joules of heat energy to increase its temperature by 1 degree Celsius. You see, that is the specific heat. And 1 kilogram of water needs about 2.26 billion joules of energy to convert from water to steam. You see, latent heat of evaporation, latent heat of vaporization is a very high value for water. Now, why is it important? If the latent heat were not that high, all the water on the earth would have become vapor by now. If the latent heat of water were very small, if only a small quantity of heat is required to convert water to vapor, there would have been no water left on the earth. So all these important properties are so useful to us. So water is designed to sustain life. Is that right? We will see more of these properties as we go on. Large amounts of water exist on the earth in the liquid form because of its very high latent heat of vaporization. And you also know that evaporation causes cooling. You see, we benefit from it. Our body heat system is regulated. Our body heat is regulated by people like us sweating and sweat getting evaporated. And when evaporation happens, heat is removed from our body. The latent heat for evaporation is removed from the body. We feel cool. So evaporation causes cooling. This property of water keeps living things cool when the external temperature is very high. Now, having said all these general things about water, let us now look at the structure of water molecule. Well, you know what water molecule is. A water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen combined together by what kind of bonding? We learned about 3 types of bonding. Ionic bond, well, basically main 2 types, ionic bond and covalent bond. Which of the 2 bonding is used in bringing together the oxygen and hydrogen to form water molecule? It is the covalent bonding, the sharing of electrons. In a water molecule, 2 hydrogen atoms share their electrons with an oxygen atom, forming a covalent bond. You understand that covalent bond involves sharing of the electrons. Now, this is what gives the formula for water, H2O. 2 atoms of hydrogen and 1 atom of oxygen makes up 1 molecule of water. All right. The shared electrons spend most of the time with oxygen atom. Now, when electrons are shared between hydrogen and oxygen, these electrons, you know, sometimes they behave very partially. Most of the time, these shared electrons spend with oxygen. That means if you take a water molecule, the end that contains oxygen will be negative because these electrons, the shared electrons, spent most of their time at the oxygen end, making the hydrogen end positive. You see, a very important concept. So if you look at a water molecule with 2 hydrogen atoms and 1 oxygen atom, the oxygen end will be negative and the hydrogen end will be positive. Why? Because the shared electrons spent most of their time with oxygen, making the hydrogen end positive. Now the hydrogen atoms are attached then to one side of the oxygen atom, resulting in water molecule having a positive charge on the side where the hydrogen is and a negative charge on the end where the oxygen is. Now, since the opposite electrical charges attract, water molecules tend to attract each other, making water kind of sticky. So, you have water molecule, one end positive, the other end negative. That means when many water molecules are put together, these molecules will all tend to stick together. How? Look at this. The negative end of one molecule will attract the positive end of the other molecule, and the negative end of this molecule will attract the positive end of the other molecule. As a result, all these molecules, water molecules, will tend to stick together. That means water is fairly sticky. You see, why is when you drop some water, what is the shape of that water? It is spherical. Now what makes it spherical? The tendency of the water molecules all to stick together is what makes a water drop spherical. Now all these water molecules attracting each other mean that they tend to clump together, making water drop spherical. A very important property of water. When electrons in a covalent bonds are not shared equally, in water they are not shared equally. The shared electrons spend most of their time with oxygen, right? Now the molecule is said to be a polar molecule. Now what is a polar molecule? Now if I call this a polar molecule, it means one end of it is positive and the other end is negative. For the case of water, the end that contains hydrogen is positive and the end that contains oxygen is negative. Water is a polar molecule. So here, this water molecule is polar because one end of water molecule is positive and the other end is negative. Now, such a polar molecule is called a dipole. A dipole. Now, the meaning of that word is pretty obvious, is that right? Dipole. Di means two poles, one positive pole and a negative pole. So, a water molecule is a dipole. It has a positive end and a negative end. So, water is made up of polar molecules. In water, molecules attract each other, forming a cohesive body. The electrostatic attraction between the positive hydrogen and the negative oxygen adjacent to molecules is called hydrogen bonding. So, what is it that holds the molecules of water together? Now, when we talked about latent heat, we said molecules in water are held together by some kind of bonding. Now, this is the reason for that bonding. The electrostatic attraction between the negative end and the positive end of two molecules. And such a bonding is called hydrogen bonding. So, in water, molecules are kept together by hydrogen bonding. The energy required to break the hydrogen bonding is what we call latent heat. And this hydrogen bonding is very strong in water molecules. Now, I have represented the hydrogen bonding by some kind of spring structure. Now, look at this. This is a water molecule, oxygen here, and this is another water molecule, hydrogen here. The positive end of one molecule attracts the negative end of the other. Similarly, in each of these cases, and these spring-like structures is actually the hydrogen bonding. The hydrogen bonding that keeps the water molecules together is very strong. In order to break it, you need to supply large amount of energy. And that amount of energy supplied to break these hydrogen bonds is what we call latent heat. The large amount of energy needed to break these hydrogen bonds account for the very high latent heat of vaporization of water. To convert water from liquid to vapor, you need to break these hydrogen bonds. And the amount of heat energy given to a liquid, given to water, to achieve that is the latent heat of vaporization. Now, one interesting property of water caused by hydrogen bonding is the change in density of water with temperature. I don't think many of you know that. It is a very interesting phenomenon. I would like to spend a couple of minutes talking about it. Now, water has maximum density at 4 degrees Celsius. Now, you know that most of the substances expand when heated. Now, what does that mean? Now, when a substance expands, it becomes less denser. That means when you cool down an object, its density will increase. Now, haven't we talked about this many times? Cold water is denser than warm water. So when temperature is reduced, the density of water must decrease. Right? Now, I did say it correctly. As the temperature of water increases, its density decreases. So conversely, when the temperature is decreased, the density will increase. Now, will the density of water go on increasing as you decrease the temperature? Now, how many of you have noticed that if you keep a bottle of water in the refrigerator, in the freezer, when it becomes ice, the bottle breaks? Why? Because water has this very peculiar property that when you cool it down below 4 degrees Celsius, instead of its volume decreasing, its volume begins to increase. Only water behaves like this. No other substance behaves like this. Well, now here I have a diagram. You can see this is density, and the density increases when the temperature is, well, when the temperature decreases, the density will increase. There you got the temperature 30 degrees, the room temperature, and we decrease the temperature. What will happen to density? Density increases. Now, this trend will continue only up to about 4 degrees Celsius. If you now cool water below 4 degrees Celsius, its density is going to decrease. It means it is going to expand. And that is why the bottle of ice actually breaks. That means water has a maximum density around 4 degrees Celsius. Now, so if I keep a bottle of water, if I keep a glass of water in my freezer, where will ice be forming first? Will ice be forming at the bottom or at the top? Well, actually ice will begin to form at the top. You know why? As the water is being cooled down, it becomes denser, its density increases, and it begins to sink. Alright, so cold water will sink, warm water will rise, and this will continue until the temperature reaches 4 degrees Celsius. Now, as the temperature falls below 4 degrees Celsius, further cooling will decrease the density. That means below 4 degrees Celsius, the colder water will begin to rise. And when the temperature is at the freezing temperature, all the freezing temperature water will be at the top. So ice will be at the top. Now, this has got great applications in aquatic life. You know, at very cold temperatures, why is it possible for fish and other water animals to survive at the bottom? If ice began to form at the bottom, no water animal will be able to survive. The fact that at low temperatures ice begins to form at the top. When ice begins to form at the top, the very cold temperature outside and the water temperature, the water is actually kept warm by the layer of ice on the top. So it is a great protective device keeping water creatures alive and well during very cold season. Now, isn't that a mystery of nature? Now look at the properties of water that has made life so much easy. Not only life for us, but life for all other creatures. But for this property, there will be no water animals living in the sea, especially at cold temperatures. So when water is cooled below 4 degrees, its density decreases and it begins to expand. This is the reason why a bottle of water cracks open when it freezes. Now, this is also the reason why ice floats in water. Big floating ice sheets near the Earth's poles keep water beneath them warm for aquatic animals to survive bitter winters. All right. Let's now talk about dissolving process. What is the dissolving process? What is the process of dissolving? A solution is a homogeneous mixture of ions or molecules of 2 or more substances. Now, very often we think that a solution is a liquid with something dissolved in it. Well, you can also have a solution of sand and salt. If you mix sand and salt, it is a solution. In other words, a solution is a homogeneous mixture of ions or molecules of 2 or more substances. When sugar dissolves in water, the molecules of sugar gets uniformly distributed with water molecules. That means if I take 1 beaker full of sugar solution and then another beaker full of sugar solution, they both will be identical in terms of the amount of sugar and water. It is a homogeneous mixture. In a solution, the material that makes up the larger part is called the solvent. So a solution has at least 2 things, is that right? 2 things are mixed. Now, whichever substance is present in a larger quantity is the solvent, and whichever quantity is the smaller, whichever substance is the smaller quantity is called the solute. The material dissolved in the solvent is called the solute. So when you put salt in water, then water is the solvent and salt is the solute. There you are, solute and solvent. A solvent will dissolve the solute in the solvent. Now, in most common instances, water is the solvent. In most cases, the gases, liquids or solids dissolved in water are the solutes. You know that very often water has gases like oxygen, carbon dioxide dissolved in it. So water is the solvent, the gases dissolved in water are the solutes, right? Now, when you make a drink with soda and whiskey, well, soda is the solvent and whiskey is the solute. Well, it depends how you drink it. Some people drink whiskey with a wee bit of soda, or some people drink it just like that. Okay, together the solvent and solute comprise the solution. So a solution is made up of a solvent and a solute. What is an aqueous solution? An aqueous solution is the solution of a solid, a liquid or a gas in water. So whenever you have a solution that is made in water, it is called an aqueous solution. I want you to be familiar with these names. Now, there are different types of solutions. Let's look at briefly these different types of solutions. Gases dissolved in gases is a type of solution. In fact, our atmosphere is a solution of gases. Is that right? Air is a solution of many gases. The second type of solution is gases dissolved in liquid. Now, when you open a bottle of soda or a can of soda, do you hear the pop sound? What is the pop sound? The pop sound is the gases that are dissolved in the liquid escaping. You see, when a soda is made, carbon dioxide, in most cases, carbon dioxide is dissolved under high pressure. When you open it, you reduce the pressure and the dissolved carbon dioxide all escape, making that big pop sound. Well, of course, you are familiar with this. The third type of solution is liquids dissolved in liquids. As I said to you earlier, whiskey in soda is a homogeneous mixture of two liquids. Then you have solids dissolved in solids. Have you ever seen a solution of two solids? Well, bronze is an example. Alloys of metal. You see, ornaments are made with gold and copper. What is a 12 or 14 karat gold? A 14 karat gold is actually a combination of gold and copper. So you can actually mix solids to make solutions of two solids. We call them alloys. Now, the forces of attraction between molecules of ions determine if one solution will dissolve in another. Now, will all substances dissolve in water? Now, water molecules are polar, but you understand that, is that right? One end of a water molecule is positive, the other end is negative. So water molecules are polar. And oils and greases are substances that have non-polar molecules. These oils and greases, the molecules do not have a charged end. They are non-polar. That means they have no positive and negative end. That means oils and greases do not dissolve in water. Why? Because polar molecules do not mix easily with non-polar molecules. Now, if you look at this here, can you see the top of the water that I'm holding? I have put some oil in it. You can see the oil does not mix with water because the oil molecules are non-polar, the water molecules are polar. They don't like each other. They don't like mixing each other. A polar molecule will easily mix with a polar molecule. A non-polar molecule will easily mix with a non-polar molecule. But a polar molecule does not like mixing with a... Now, you know why it happens? You see, water is polar. That means they have positive and negative end. They are very cohesive. They want to stay together as a body. When oil molecules come in, they say, get out, get out. We are cohesive. We want to stay together, positive to negative, positive to negative. You see that electrostatic attraction keep the molecules of water all together. Oil cannot get in there. They'll be simply chucked out. Now, carbon tetrachloride is a liquid that has non-polar molecules. That means if I put this oil in this liquid, carbon tetrachloride, it will immediately dissolve. So oils and greases will dissolve in carbon tetrachloride. Well, you also know that oils and greases can easily be washed off by using gasoline. Again, gasoline contains a lot of non-polar molecules. Soap molecules have one part that is polar and another part that is non-polar. Now here is a mediator. A good mediator is soap molecule. Now what is the characteristic of soap molecule? Soap molecule actually has a polar end and a non-polar end. You see, the polar end of the soap molecule makes friends with polar molecules, and non-polar end of the soap molecules can make friends with non-polar molecules. That means soap can actually make peace between polar and non-polar substances. All right? You know that soap can be, oil can be washed away from your hand using soap. What actually happens there? The soap molecule will act as a mediator by attaching itself, one end of it to water and one end of it to oil. That way you can remove it. You see? That is a very... Now, if I put some soap in it, this oil will simply dissolve because the soap will help that process. Now, I put some soap in this water and look what it did to the oil. It has actually, the soap has actually helped that oil dissolve in water. You can see the water has actually even changed its color. All that oil has actually dissolved in the water. Now what has happened here? The mediator, which are the soap molecule, look, I have a good solution of soap, water and oil. The mediator is the soap. Soap molecules, one end of it is polar, the other end is non-polar. The polar end will make friends with water. The non-polar end will make friends with oil. So one soap molecule will, one end of it will attach to a water molecule, the other end will attach to an oil molecule, and that means all of them can now mix together. Isn't that good? Well, when soap is used to wash off oil, the polar end of the soap molecule is attracted to the polar water molecules, and its non-polar end is absorbed into the oil, washing the oil away. So that means what we said so far, is like substances dissolve. In other words, polar substances dissolve in polar, and non-polar substances will dissolve in non-polar substances. So the rule like dissolves like applies to most solutions. Sodium chloride consists of an arrangement of positive sodium ions and negative chlorine ions. We have seen that earlier. Now, this is what sodium chloride is. When you put this sodium chloride in water, what happens? Well, these ions will actually separate. How? When sodium chloride is mixed with water, the negative ends of the water molecule get attracted to the sodium, the positive sodium ions, and the positive end of water molecule get attracted to the chlorine ion, now pulling them apart. And that is what happens. This is the mechanism of dissolving. So the water molecule, the positive end of the water molecule will pull on the negative end, the chlorine ions, and the negative end of the water molecule will pull on the sodium end of sodium chloride. That way the ions are separated out. That means when salt is dissolved in water, they go into water as sodium ions and chlorine ions. The attraction of water molecules to ions is called hydration. You can see the reason why sodium chloride dissolves quickly in water is due to that property of hydration. The water molecules will attract one end of the water molecule will attract the sodium, the other end will attract chlorine, pulling them apart. So systematically, sodium chloride, the solid, is broken down into ions. You see, hydration is one important way by which rocks and minerals break down in nature. You know that almost all the soil we have on the surface of the earth is produced by breaking down of the rocks and minerals. Now, one of the ways rocks and minerals break down is when water gets into crevices, the molecules of water start pulling positive and negative end of ions of minerals, breaking them apart. So gradually the minerals break apart, and this process is called hydration. If the force of hydration is bigger than the force holding the ions in the solid, then they come apart and dissolve in water. Now, sodium chloride dissolves well in water because the force of hydration. What is force of hydration? The force water molecules applies in pulling the atoms apart. If the force of hydration is greater than the force that is holding the ions together in the solid. In sodium chloride, listen carefully here, if the force between sodium and chlorine ions is greater than the force of hydration that water can apply, then sodium chloride will not dissolve in water. Sodium chloride dissolves in water because the force of hydration, that is the force the water molecules can apply, is greater than the force between sodium ions and chlorine ions in sodium chloride. Now, a solution of sodium chloride in water therefore consists of positive sodium ions and negative chlorine ions uniformly distributed in water. That means, and this is our sodium chloride, NaCl, which is an aggregate arrangement of sodium ions and chlorine ions. When it is put in water, sodium ions get separated from chlorine ions. If the attraction between ions in the solid is greater than the energy of hydration, the ionic solid will not dissolve in water. Okay, we were talking about solutions. So it is time now we talk about concentration of solutions. What is the meaning of concentration of solutions? Concentration refers to the relative amounts of solute and solvent in a solution. Now, a solution that contains a large percentage of solute is called a concentrated solution. So, a concentrated salt solution will contain large amounts of solid dissolved in water. And one that contains a less percentage of solute is called a dilute solution. So a solution can be a dilute solution or concentrated solution. Now here I have a dilute solution of hydrochloric acid. It means this is a solution of small part of hydrochloric acid with large part of water. This is a dilute solution. On the other hand, a concentrated solution of hydrochloric acid will contain lot more hydrochloric acid than in the dilute solution. So distinguish between a dilute solution and a concentrated solution. Now, how do we measure concentration? Sometimes concentration ratios are given in parts per million. Look at this, ppm. Very often, if you look at labels in medicines, you have these kind of usages. Parts per million, ppm, or parts per billion, ppb. And it can be by mass or by volume. So if it is by volume, on the label you will see by volume. In other words, parts per million per volume or parts per million by mass. For example, a solution of 200 ppm by volume of ethanol in gasoline. What does that mean? 200 ppm by volume of ethanol in gasoline means that 1 million liter of the solution contains 200 liter of ethanol. That is the meaning of 200 parts per million in volume of ethanol in gasoline. If you take 1 million liters of that solution, 200 liters of that will be ethanol. That is the meaning. On the other hand, let's see how we say that parts per million in mass. 1000 ppm by mass saline solution means that 1 million gram of the solution contains 1000 gram of salt. You see, 1000 ppm by mass means 1 million gram of the solution contains 1000 gram of the solute or the salt. Now, water used for irrigation of crops should not contain more than 700 ppm of total dissolved salt. Well, actually seawater contains a lot more than that. Therefore, you cannot use seawater for irrigation. Concentration can also be expressed as a percent by volume or percent by mass. How do we write that? Suppose we say a 20% solution by volume of rubbing alcohol. Now what does that mean? 20% solution by volume of rubbing alcohol. It means if you take 100 milliliter of the solution, that 100 milliliter of solution will contain 20 milliliter of pure alcohol. That is a 20% alcohol solution. Now, percentage by volume of a solute can be written by a formula. Look at the formula there. Percentage of solute by volume means volume of the solute divided by volume of the solution multiplied by 100. So, in this case, we get 20% by doing this. In other words, 20 milliliter divided by 100 milliliter multiplied by 100 gives you 20%. On the other hand, what does this mean? 15% by mass of sugar solution. What's the meaning of that? 15% by mass of sugar solution. It means if you take 100 gram of that sugar solution, 15 gram of it will be sugar. That is the meaning of that. And percentage by mass of a solute can be written as the similar formula. Percentage solute is mass of solute divided by mass of solution multiplied by 100. I want you to learn how to use this in solving simple problems. Now, concentration of salt in seawater is measured in yet another way. Look at the representation we use for that. Concentration of salt in seawater is measured as the mass of salt in 1000 gram of seawater and is represented by this peculiar symbol. You see, it looks very similar to the percent symbol, is that right? But this is, a percent symbol has a 0 to the left and a 0 to the right of the slash. But here we have a 0 to the left and 2 zeros to the right. So it is not percent, but it is per thousand. So concentration of salt in seawater is measured in what unit? Per thousand. Now, if you say this, can you read this and tell me what that means? 42 per thousand means 42 gram of dissolved salt in 1000 gram of seawater. That is the meaning. 42 per thousand means 42 gram of salt dissolved in 1000 gram of seawater. Let's do a small problem. A cocktail drink is made by mixing vodka with lime juice. If 50 milliliter of vodka are used in making 400 milliliter of the drink, what is the percentage concentration of vodka in the drink? Well, what we need to do is go back and pick our formula. What's the formula? Percentage vodka is volume of vodka divided by volume of drink multiplied by 100. Now, what is the volume of vodka given to us? It's 50 milliliter. What is the volume of the drink? 400 milliliter. So that will be 50 milliliter divided by 400 milliliter multiplied by 100. And you should know how to do that. Is that right? And that is 12.5% is the concentration of vodka in that solution. Another one. 120 gram of sugar are dissolved in water to make 500 gram of sugar solution. What is the percentage concentration by weight of sugar in the solution? Now this time I have given you these quantities in mass. Now what is the formula for percentage concentration by mass? Percentage concentration of sugar is mass of sugar divided by mass of solution multiplied by 100. And we have both these values. mass of sugar. 120 grams of sugar is dissolved to make 500 grams of the solution. So the percentage of sugar will be 120 grams divided by 500 grams multiplied by 100. That is 24%. Another little problem. What is, alright, how do I read this? Could you remind me? What is the per thousand concentration of salt in seawater if 8 grams of salt is contained in 20 grams of seawater? Well, remember, the concentration of salt in seawater is measured per thousand. Now, we got 8 grams of salt dissolved in 200 grams of seawater. And therefore, can you tell me how many grams of salt will be in 1000 grams? It's very simple, because most of you know how to calculate these simple questions. Is that right? Yes. If 5 people eat 10 cookies, how many cookies will be eaten by 20 people? You know that. So 8 grams of salt are dissolved in 200 grams of seawater. How many grams of salt will be dissolved in 1000 grams of seawater? You see, you can do it quickly like this. 200 can be made 1000 by multiplying by 5. 200 times 5 is 1000. So multiply this 8 grams also by 5, it will be 40. Means 40 grams will dissolve in 1000 grams of seawater. Well, percentage, per thousand concentration is mass of salt divided by mass of solution multiplied by 1000, not by 100 this time. The only difference is for a percent, you multiply by 100. To make it per thousand, multiply by 1000. So it will be 8 grams divided by 200 grams multiplied by 1000. That is 40 per thousand. Alright. We will now talk about another way of measuring concentration, and it is called molarity. What is molarity? In chemistry, very often concentration of a solution is measured in a unit called molarity, and we will represent it by the uppercase M. The amount of a substance is measured in a unit called mole. What is a mole of substance? Well, in chemistry, that is a very important quantity. 1 mole of any substance contains the same number of its elementary units, that is, atoms or molecules. For example, if you take 1 mole of water, that 1 mole of water will always contain the same number of molecules. If you take 1 mole of hydrogen, that 1 mole of hydrogen will also contain the same number of atoms. You see, 1 mole of carbon, 1 mole of copper, and 1 mole of iron will all contain the same number of atoms, which is the same as the number of molecules in 1 mole of a substance. You see, the number of atoms in 1 mole of an element and the number of molecules in 1 mole of a compound, they are all the same number. This constant number is called the Avogadro's number. Avogadro's number, and represented by the uppercase N. And this is the Avogadro's number. Avogadro's number is N equal to 6.02 times 10 to the power of 23. Now, this many atoms will be contained in 1 mole of any substance. This many molecules will be contained in 1 mole of any substance. That is the significance of a mole. Now, how many molecules are there in 1 mole of carbon dioxide? Tell me, how many molecules are there in 1 mole of carbon dioxide? 1 mole of any substance will contain the same number of molecules. That means 1 mole of carbon dioxide will contain this many molecules. 1 mole of water will contain the same number of molecules. 1 mole of aluminum contains 6.02 times 10 to the 23 atoms. 1 mole of carbon dioxide contains 6.02 times 10 to the 23 molecules. 1 mole of this substance, which is a hydrochloric acid, 1 mole of hydrochloric acid contains 6.02 times 10 to the 23 molecules. So, what is the meaning of a mole? 1 mole of any substance contains the same number of elementary units. If 1 mole of any element contains 6.02 times 10 to the 23 atoms, 1 mole of any compound contains 6.02 times 10 to the 23 molecules. Now, to give you an example, how much is 1 mole of water? In other words, how much water will contain 6.02 times 10 to the 23 molecules of water? It's about 18 grams. It's called the molar mass of water. So molar mass of water is 18 grams. 18 grams of water contains 6.02 times 10 to the 23 molecules. So, why did we say all this? To talk about molarity. The concentration of a solution is measured using molarity. What is molarity? Molarity is represented by the uppercase M. And what is the definition of molarity of a substance? Is the number of moles of a solute contained in a liter of a solution. The moles per liter, molarity of a solution is measured in moles per liter. How many moles of a substance is dissolved in 1 liter of the solution? 2 moles of sodium chloride making up 1 liter of a solution has a molarity of 2 moles per liter. Now, this solution, this is a solution of hydrochloric acid. The label says 0.1 molar. Now, 0.1 mole. In other words, this solution contains 0.1 moles of HCl, hydrochloric acid, in 1 liter of water. So if you take 0.1 mole of pure hydrochloric acid and make up 1 liter of the solution, that is a 0.1 mole solution. Alright? The mass of 1 mole of a substance is called the molar mass of that substance. And the molar mass of all different substances will be different. But if you take 1 mole of any substance, it will contain the same number of basic particles, atoms or molecules. Now, the molar mass of sodium chloride is 58.5 grams. It means if you take 58.5 gram of sodium chloride, it will contain 6.02 times 10 to the 23 molecules. Actually, they are not molecules, aggregate ions, the particles. This means that 58.5 gram of NaCl, sodium chloride, contains 6.02 times 10 to the 23 ionic units. What is an ionic unit there? A unit that contains a sodium ion and a chlorine ion. Now, 1 mole of carbon has a mass of 12.01 gram. It means if you take 12.01 gram of copper, it will contain 6.02 times 10 to the 23 atoms. That is the meaning of 1 mole of a substance. If 58.5 gram of salt is dissolved in water to make 1 liter of a solution, can you tell me what is the molarity of that solution? 58.5 gram is 1 mole of sodium chloride. So 1 mole of sodium chloride is dissolved in water to make 1 liter of a solution. We say the molarity is 1 mole per liter. Now, if I tell me now, if you can listen and concentrate, instead of 58.5 gram, if I take 5.85 gram of salt and dissolve it in water to make 1 liter of solution, what will be the molarity of that solution? Well, it will be 0.1 mole per liter, because I have taken 1/10 of a mole. 5.85 gram is 1/10 of a mole. 1/10 of a mole, or 0.1 mole, is now dissolved in water to make up 1 liter of solution. The molarity will be 0.1 mole per liter. Molarity M of a solution is defined as, look at the way we define it. Molarity M equal to moles of solute. How many moles of solute are dissolved? That's the mass there, divided by liters of solution. So the number of moles of solute divided by the liters of solution will give you the molarity. Okay, let's use that to do a small calculation. The molar mass of HCl, now that's what I had just shown you. This is HCl, hydrochloric acid. The molar mass of HCl is 36 gram. What does that mean to you? Do you understand that statement? The molar mass of HCl is 36 gram. If you take 36 gram of this HCl, it will contain 6.03 times 10 to the 23 molecules of HCl. That is the meaning that the molar mass of HCl is 36 gram. How many moles are there in 144 gram of HCl? Can you do that in your mind? That's very easy. Look at this. The molar mass of HCl is 36 gram. That means if you take 36 gram, it is 1 mole. 72 grams is 2 moles. Is that right? So 36 times 2 is 72. Alright, can you tell me 144 gram is how many moles? 36 gram is 1 mole. It means 72 grams is 2 moles. If you multiply 72 by 2, you get 144. So 144 gram will be 4 moles. So, if the molar mass of HCl is 36 gram, then 144 gram of HCl is 4 moles of that substance. Okay, the next part. If 144 grams of HCl are dissolved in water to produce 2 liters of solution, what is the molarity of the solution? Well, what's the formula for molarity? It is the number of moles of solute divided by the liters of solution. Is that right? That will be the molarity. So let's do that first. The number of moles equal to mass of the substance divided by its molar mass. Mass of the substance is 144 and its molar mass is 36 grams. That means 144 grams contains how many moles? 4 moles. Now you can find molarity. 4 moles of HCl is present in 2 liters of the solution. And therefore, what is the molarity? Molarity M is moles of HCl divided by liters of solution. Moles of HCl is 4. Liters of solution is 2. That will be 4 moles divided by 2 liter. That will be 2 moles per liter. The molarity of that solution is 2 moles per liter. Okay. I will record another part of this lesson a little later. So at the moment we will stop with molarity and we will continue with solubility in the next part of the lesson.